Can everyone see my screen?
Yes.
Perfect. Just want to make sure. So yeah, thanks everyone for coming through. I appreciate you taking the time out of your day to attend my talk on root canal surgery, where today we're going to have a look at really looking into the root cause of different sort of software issues and how you can better tackle it. I do want to start off though with my talk with a slight caveat, and that's to apologize for people that might have been attending this talk looking for a different problem. If you have some toothache, if you're struggling with anything to do, with real, tooth-related problems that require a real root canal surgery, please go see your dentist. I just thought I would start off with that sort of slight, anecdote and joke. But a little bit more about me. Elena did introducing myself, but yeah, my name is Craig Risi. I am a QA architect for a company called REPL, which is part of Accenture. I love software testing. I love software quality, and in particular quality by design. I also have a lot of hobbies, one of which is board games, and so I have a company called Risky Games where I also release and publish my board games. And I have a book out called Quality by Design, which is really about designing software quality software from the beginning. So not just looking at it from a pure testing perspective, but how do we design software to actually be of better quality? And so that's a topic that interests you. I'd really encourage you to possibly try and read it. It is available on most digital platforms. Yeah, if you're interested in that, I'd really encourage you. And if you're wondering about my accent and wondering where I'm from, I am from Cape Town, South Africa. So I thought I'd also just share a brief snapshot of my life and why I chose to live in this beautiful city and beautiful part of this world. Really is a beautiful place, and all the pictures you see are from the city which I stay in and within about 50 kilometers of my house. So I really love being here and love representing the city and my country to the global audience. But back to my topic, which is really about getting to the roots of the problem. And to me, this is something which I'm really passionate about, because I think as software developers and software testers, we can spend a lot of time obviously testing our software, building our software, and then we find issues and then we fix them. But I don't sometimes think we spend enough time to really try and understand, why did the issue occur in the first place? What went wrong in our process that enabled this particular issue to happen? And really, I think it's something worth exploring. How do we dig deeper into understanding what's really going on with our software? Because we can really often just have a look at what the symptom is. So what actually does it look like went wrong with the software, rather than understanding where the real problem lies. And I think more specifically, then what is actually causing this problem? And I feel like if we don't fully understand the problem, I think we struggle to really understand what it is that we need to do to really be able to fix it long term. And I've got this quote up saying that we tend to fix symptoms rather than root causes. And I think this is a particular issue that I have, because if we spend too much time focusing on just trying to fix the symptoms of a problem, I think really what you find is, I think firstly, and I'll start with the top right, we tend to waste effort, because what happens, and I've seen this many times, we fix the symptom of an issue. Say for instance, you're finding a defect, and there's a particular issue in the code, and it's all fine. You found it, the developers found the fix. We move on, they move on, but in the next sprint, the same issue happens and the same incident occurs. We find the same type of defect, and then you find that happen on a regular basis. You're constantly finding the same issues, and you're never really getting better. You're just finding bugs, fixing bugs, finding bugs, fixing bugs, without really gaining headway on trying to reduce the overall defects that you're identifying. And I think that's thing. So it's wasted effort, because you're doing a lot of testing, you're spending a lot of effort constantly repeating these mistakes, and so what you really want to do is try and get to a point where you're spending a lot of less effort repeating the same things, and rather focusing on newer problems, focusing on developing new features. You shouldn't be going in trying to develop or constantly fix the same type of bugs. You're increasing your testing effort, because as testers, you're constantly falling over the same parts, and the same things. You're finding the same type of bugs, and even if it's not necessarily the same bug and you fix it, it can be the same type of bug. So something that's related and you're not aware that it's related, and every single sprint or every single iteration of your code, you think, okay, we're like finding these defects and we're fixing these defects, but it's the same type of defect that you're constantly identifying. And by not digging deeper into the root cause of why these types of defects occur, or maybe not even aware that these defects may all have a similar sort of root cause, you're spending a lot of extra time, again, with extra testing, with a lot of effort being wasted. You also tend to create your technical debt. So because there's all these defects that are constantly being introduced into your system, it slows things down. It prevents your team from being able to develop new features. You end up having to spend a lot more time on maintenance, on things around getting your application right. And also it can be sometimes, and we'll go into a little bit later on in terms of maybe some of the bigger issues of what could cause some of these software defects. But also from a technical debt perspective, sometimes you can put off really big, important software developments and changes, and you're not really able to make headway on them because there's all these defects that you're constantly fixing, or you're just realizing, we actually don't want to make this change because of all these software defects, and you're really putting things on hold, and that's not a healthy position to be in. You really want to be able to start dealing with your defects, and you shouldn't be creating technical debt, which is now all these latent issues that need to get fixed in your software that maybe you're not aware of. And lastly, obviously, all of that just means excess maintenance, slower delivery. We want to move fast. We want to be able to deliver software very, very quickly for our clients. Whatever your line of business is, the sooner you can put features out into the world, the better it is. And I think it's very important that we really try and work on that within our software. And so if we're seeing symptoms of issues within our teams, we don't realize that we're actually slowing ourselves down. And I think this is an important thing. And I think, and one of the things I do want to say with this is that I think often it's that caveat of teams don't want to take the time to delve deeper into an issue because they find an issue and they're like, okay, well, let's just quickly fix it and move on. And you think you're saving time by doing that, but often what you're doing is just adding future time onto the rest of your future iterative cycles. And that's an important thing which we want to try and avoid, is that when you find issues, actually sometimes slow down, spend more time looking at the issue to be able to say that we really understand what went wrong so that we can prevent it, so you don't have to do that future work later. And that's really what dealing with symptoms causes. It really slows us down as a team. We end up wasting a lot of effort. We find a lot of bugs. We do a lot of repeated testing, and it's just technical debt that gets created along the way, which is not healthy from a software development perspective. I think it also creates, and this is a big one, which is why I gave it a separate slide, it creates a culture of bug fixing, where, like I said, we're used to being in teams where we find bugs, we fix bugs. And I've seen a lot of teams often incentivize their testers on the number of bugs they find and then the number of bugs they get fixed as developers. And so they then start to celebrate, we found so many bugs, we were great, we did some great testing. And then they go to the devs and they're like, devs did a great job, they fixed all these defects, so we're in a good space. Our testing team's working, our dev team is working, this is great. But that's actually not what should be happening. We shouldn't be constantly finding bugs. We should be getting to a point where every single iteration of our software, we should be finding less defects and less bugs. And obviously early on in a software development cycle, that might not always be the case because you're still finding your feet with your architecture and as a team. But really, as your software development matures, you should be finding less defects and less defects and less defects. And as your team gets better, they should be producing or introducing less defects. It's not healthy to have a culture in your company where you're constantly finding defects and fixing defects. We shouldn't be celebrating it. We should be celebrating when we have identified less defects than the previous time. When our testing is coming with positive results or we're not finding anything, we should be celebrating that and not thinking, as testers, we need to find more defects, we need to find bugs, we need to ensure that there are a lot of bugs to show our worth. I don't think that's healthy. Our job as testers should really be to prevent defects from happening, not to find them all the time. And I feel like if we're not delving deeper into issues, we're creating this culture where we're just trying to identify defects and bugs all the time. We shouldn't be wanting that. We should be trying to find ways of finding less bugs, and rather celebrating that the effort we put into really understanding the root cause of issues and what went wrong with the software build and what went wrong with the software development process, whatever it might be, that it's now working and we're now getting less defects in our cycle. And that's what we should be trying to do. And that's the culture that we should rather be celebrating within. And I feel like we don't do enough of it, which is why I think it's a very dangerous culture to have in a company. And I think it's one of the reasons why you don't want to spend too much time just trying to fix symptoms of issues, because it will create this culture over time. And so it's very important that we don't do this. But yeah, so we obviously want to then talk about getting to the root of the problem. So we understand, okay, we shouldn't be fixing symptoms of our issues. We really don't want to create that type of culture. We really want to understand what's going on and what's causing those deeper issues in our software. So how do we go and get to the real root of the problem within our software and understand what's really going on? Because I think that's obviously the bigger issue, is that how, is now looking at what's going on, looking at what defects manifested themselves, and now trying to identify, well, what actually is going on? How do we dig deeper into the process? And I think that's really what this is about. And so, I want to start off obviously by talking through the typical sort of bug life cycle, because I think that's important. Now, your bug life cycle might look a little different than this one, but this is, I would say how most of us kind of work. We would have a bug life cycle where we would have a new defect, we would raise the bug, get assigned to someone, they would fix it, we would retest it. If all's good, we would verify it and close it. If it's not, we might reopen it and start the cycle again, or it might get assigned and then rejected, deferred, or for whatever reason, we then make a decision we're not going to fix it, or we're happy with it the way it works. And that's typically how things work. And what we normally try and aim for is we're logging the defect and then we want to close it. My issue is that sometimes I think we rush the process to get to closed too quickly. And the question I like to ask teams is, if you don't know what caused the issue, can it really be closed? Yes, you fixed it. So the dev has gone in and they've said, okay, we found the bug, we found what caused the bug, or what we think caused the bug. Let's just quickly fix it and close it. I just have a bit of a bigger sort of question, is if you as a tester feel like you're not really comfortable with fully and it seems to be working now, so you're going to close the bug. But why did the bug occur in the first place? What part of the process caused the developer to maybe misunderstand what needed to get done? Maybe the requirements were incorrect. Maybe we didn't have a good understanding of how to build this in the first place. Maybe our test data was wrong. Maybe the dev's test data was wrong. Maybe the dev didn't have a good unit test in place to understand it. Maybe there's problems with our test environments. There could be a variety of issues. But if we don't really understand what caused this issue to be introduced in the first place, and was it just a general mistake? And I'm not trying to say there's anything wrong with that. We're all human. We're going to make mistakes. No developer is perfect. We're always going to make coding mistakes along the way. That happens. But if you don't know what really caused the issue, and you don't feel, how can I say, confident that it can be prevented the next time, and I think this is an important thing. If you can't guarantee how to prevent the issue from reappearing, have you really fixed it? And so I think what I'm trying to say here is we rush too fast to try and close defects. We find it, we try and close it as fast as possible so we have less bugs on our board. Whereas I think what we should be doing is rather slowing down and saying, okay, maybe we need to fix it. And I'm not saying we shouldn't be fixing our bugs. We need to fix them as fast as possible so that our software, particularly if it's a really important major defect, so that we can ensure that it's addressed and that the users can use the software with that feature again without that issue affecting them. But rather than rush to close it, we should rather take some time out and understand, well, what did we miss? Where did we get it wrong? Why didn't we think of the scenario? Why did we build it the way we did if it's not quite fit for purpose? Why did we make this coding mistake? Was there anything we could have done to prevent this coding mistake from happening? Maybe there's a process or something we can put into place that can help developers in the future not make these same mistakes again. And I think that's really what we're trying to address through this whole process, is really trying to find a deeper way of being able to look at software issues and what's going on with the underlying software to be able to get better. And so it's really about that purpose of looking at a root cause. So how the defect occurred, and then what can be done to prevent it from happening again, and making sure we're confident of that. And I'll go through some examples of things that we can do. But I think this is very important. And I think another sort of thing that's important is we often hear this thing of devs and testers sometimes working very, very separately from each other. And I think what's important is when we're doing this, it helps to foster that collaboration. We shouldn't be thinking, testers are finding bugs, throwing it over the developers have got to fix them, and then we have also not a healthy culture to have. By looking deeper at the root causes, what it should do is help us to work together as a team, because you as a tester shouldn't be saying, oh, I found this bug, throw it over, and then you stop and then you move on to do more testing. You should rather then also take the time out with the how do we get better? Let's have a look at the code. Maybe the code is complex. Maybe there's something that we can do to redesign this code so it won't be so complex next time, so that we can ensure that future development work on it will introduce less defects. There's a variety of things that we can go through, but what it does is it actually brings the team together, which I think is another healthy benefit of this. And I thought it'd just be worth mentioning that, because I think if we don't do that effectively, we can create this culture of testers versus developers, which I also, again, I don't like that. What we should be doing is looking at how do we get better at designing our software and developing our software, and that's what you want to do. And that's the idea of looking into root cause as well. So we want to make sure that we can prevent issues from happening, and in the process, it's really going to foster really good team spirit, really good team development, because we're working together now as a team and really looking to understand our software a lot better. So how do we do that? So what, and I think a key thing is obviously asking ourselves some questions, because we've obviously found these issues, but now how do we actually really understand what's going on? And I think if we start asking the right questions, that starts to lead to us really understanding the root cause of the problem, because sometimes we don't know. We found an issue, we fixed an issue. How do we know that we've really understood its root cause properly, and that we've correctly addressed the issue and make sure that we can prevent this issue from happening in the future? And so asking some of these questions will help you better understand what actually went wrong and identifying the actual root cause, so that you can be in a better place to be able to really say that you can now prevent this issue from happening. So first question, obviously, what does a defect issue look like in production? I think that's an obvious one. When we find a defect, we see something happening, it's making sure that we fully understand what it actually looks like. Can we reproduce it? Do we understand the data that led to that happening? Very important things. What's causing it to occur? What particular things? Again, if we're not able to fully comprehend why the issue happened, I've often heard testers say, well, this wasn't reproducible, or I couldn't reproduce this issue on my side. It can't be that critical. To me, I get concerned by that, because if we can't understand why an issue happened, even if it's just periodic, that means that we can never control it. We can never say that we've got rid of it. It's always going to be an issue. Customers will always, at some point in time, come back and complain about it because we don't fully understand it. We've got to understand what's causing it to occur, what events happened, where is it occurring, which part of the software, which part of the application. Obviously, there's the how do we fix it, which I think is important. I think we're good at that, or at least I think a lot of teams are good at that. But it's important in understanding a little bit more of those details. And then how do we ensure it doesn't happen again? Obviously, that big thing. Do we understand it enough to be able to say that this will never happen again? And if not, we've got to start asking even deeper questions. Things like, so we're not so sure what to do. How do we identify things better? Well, let's go through the entire process and start looking at these things. So we need to start asking ourselves specific questions like, do we really understand what needs to happened? We missed it somewhere along the line in the development process, like dev has got something and they produced something. The testers looked at this and said, "This is not quite what I expected. My tests are failing." Was there some ambiguity? Can we do a better job at defining things for a team to prevent that type of thing happening? Did we make any technical assumptions? And I find this is a big thing that's often overlooked. We write requirements, we write user stories, and we sometimes just assume some implicit sort of technical details around how this is going to be implemented. But the problem is every developer and every tester and every person on a team comes from a different background and different expertise and different skill sets. And even if you've been your team has been working together for a while, there's always going to be something different that you're coming from. And there might be technical assumptions made about how you think a particular thing is going to work in terms of its architecture, maybe some specific things that you think in terms of how it's designed. Oh, we should, we always design systems this way. This is the architecture we use as a company. But was it the right architecture to use? Something worth investigating. We maybe made some technical assumptions that we shouldn't have because we didn't fully understand how this should have been done in the first place. We've got to start asking ourselves that question to properly address it. Was there any data constraints that could have been causing this issue? Are we aware of all sort of data permutations? Data is a really tricky thing in the testing world when it comes to trying to understand what's causing issues. Did we have the right data in place? Do we understand the data that's needed? Do we understand what type of data our clients really need, and were we using representative data in our test environments, and if not, why not, and how do we better understand what our clients need and the data that they're using so that we can better replicate that? It's understanding those things and maybe delving deeper into those specific issues to see, well, we need to then change our data, change the way that we work with test data to be able to produce better quality software. How does it impact security and performance? And I think this is an important thing. Again, sometimes it's not necessarily related to the issue itself, but anything can have a knock-on effect with security and performance. So it's understanding that this particular defect, obviously, does it have any direct impact on the performance of the software, on the security issue of the software, not just how does it functionally render, but then any sort of subsequent fix. Is there anything that could affect the security of the software performance afterwards? Understanding that and making sure that we fully comprehend what is going on with the software and with these issues. Are there similar pieces of code used in the software? Another sort of common question that we should be asking ourselves, because again, even if we think that this issue is isolated, in the software development world, we're constantly reusing code. We're constantly sharing functions and sharing packages and sharing modules all over the place. And this is important because sometimes logic that affects one piece of an application is likely going to affect somewhere else, even if we think that they're completely separate from each other. Even if the code is separate, sometimes the logic or the approach that we is the same, or they might be sharing a common package which has got an issue in it. And then what we do is we just fix the one issue that we found without actually fully understanding, but there's a whole bunch of other pieces of code that actually use the shared code. We need to look into that as well and maybe fix those issues because they could surface in the future. And actually taking the time to understand what is going on and is there anything else impacts it. And I think very important as testers, how can this code be tested better? And we've got to always be asking ourselves the question as testers, how do we get better at testing? If we find a bug in our testing process, that's great. If there's a bug in production that goes through, we've got to start asking ourselves this question. We need to do better. And yes, we could say that some issues you'll never find. Customers will always find things that you'll never find. And there is some truth to that, but that doesn't stop us or doesn't excuse us from getting better. There is something that when a customer finds an issue, it's trying to understand, okay, the customer found this issue. Why didn't we think of this data? So maybe we did, and we knew we could never reproduce this in the test environment, and you're comfortable to live that there might be a few issues that you're going to face because some things were just too difficult for you to deal with. But as much as possible, it's worth asking yourself, well, actually, how do we get better at this? How can we test these situations better within our environment and making sure that we do it? And it's important to understand those questions. But I think it's a lot more than that, because you might be asking yourself, but Craig, we can't take every single defect and issue that we're facing and ask these questions. I mean, this is a lot of stuff. If you have to find every single little bug that you're logging, and now you've got to delve and ask these questions every single time, you're never going to have time to move forward with your software development. And that's true, particularly if you're part of a large company or a large team where you've got 20, 30 different sprint teams, all operating, working on different features, and they all find various issues every single day. If you're trying to find the root cause and document what's going on in every single one of them, you're never going to move forward because you spend too much time constantly trying to find these things. And I think that's why trend analysis is so important. I think this is going to be one of the key things that I want to take away. We're never going to identify the root cause of every issue, but I think by using trend analysis, we can certainly start to understand these things better. And I've got this quote from Albert Einstein where it's like, if you want to know the future, you've got to look at the past. And I think that the whole purpose of trend analysis is about trying to understand the past within your issues, having a look at your issues, and maybe you don't have time to delve deeper into every single issue and what's going on, but if you can at least roughly understand the different defects and different things that you're facing, it puts you in a better space to be able to start looking back at what went wrong and start to better identify how to fix it. You might not be able to address every issue, but you can certainly start to address some of the major issues that are going wrong within your software space. So what I mean by trend analysis, I've got this thing around like prioritize, and I've got this example here where you've gone and you've done some rough sort of assessment where certain percentage of defects, issues were related to requirements. You're not going to go and every single defect when you find, okay, this is related to requirements, go and now iron out every single requirements issue you're having. But what you do know is, in this particular example, roughly 16.9% of all the issues that we picked up, we felt were related to requirements in some way. We haven't gone in and we haven't prevented all these things from happening, but we know that that's what it's about. We know that 26.8 has got to do with code issues or design issues, security, whatever it might be, bad fixes. All of these could be things that are going wrong. So we as a team or we as a company know that we can't deal with every single issue, but if we know that, in this case, that design and code are the biggest issues within our company, we can start looking at our coding practices. We can start looking at our software design and say, well, how do we get better? Let's just tackle those two issues so that we can find less issues in them in the future. And then we can move on to requirements, which is the next big thing there. And let's see how we can better define our requirements for our software better. And we start tackling off those bigger issues, because sometimes it's not just about you as an individual team, it's about you as a company. Some of these things can be company trends, and you as a team might be finding issues, but there's other teams finding the same issues. If we're not addressing it at a corporate level, again, each team is going to be reproducing the same problems, and that's not healthy as well, which is why it's also good to sometimes take this and actually keep track of everything, so that you can have a look at it from a broader, organizational level to be able to deal with it better. Other things to kind of consider is defect types. So, and I'm not going to go into detail on what the different defect types mean here, but it's it's understanding the difference between what's a feature defect, what's a regression defect, performance data, historic. Well, what's known? A known defect is something that you knew about already. You knew it was going to be, an issue. You chose not to fix it as a team, so you've logged it, but you've now marked it. We know this is an issue. Sometimes that's historic. You find an issue, but then you realize it's been there for like 6 months. That's historic. We're not going to maybe rush to trying to fix it because it's been there for a long time. It didn't cause any issues then. But just understanding again the nature of the defect, very important, and you can start to categorize these things. And I think when I talk about this section where we're really trying to understand these defects, it's really starting to categorize them using our defect management tools that we have. Categorize them and actually don't just say I logged a bug. Once you understand the bug, identify the bug. What type of bug is it? This is the defect type that it was. Finding things about what module was affected, which piece of code were actually impacted by this defect. Those that we know, and then maybe those, for instance, when there's shared code, those that also might be affected, and actually documenting that. Which part of the application, the business process code, is this failure constantly occurring? What's the importance and complexity of that module? Maybe it's a really complicated part of your application, and you're expecting to find more defects. But if you know it's complicated, you can kind of work with it. Maybe it's a bit more simple, but it's worthwhile classifying that sort of thing so that you can, again, work with it as an organization. The root cause. So these are specifically when it comes to things around dealing with root cause of your software. Coding errors. So what are the coding errors that you're facing? Design errors. Maybe you found some design errors, data errors that you're finding. Deployment errors was an error in the deployment process that needs to be fixed. Environment errors. Those are issues with your specific test environment. So that's when certain things are passing in different environments, and you need to understand why. And it's delving into those things, performance errors, being able to, again, classify these things specifically as this is what's causing the problem. If I can put it into this way, this is often what you see. This is kind of the root of what you want to try to do. You know that you have a requirements issue, or coding issue, an environment, or a testing issue, but then you start going even deeper to say, well, this was the reason. It was a testing issue because the requirement was tested in the wrong way. Now, that could be both a requirements issue, it could be a testing issue, but in this particular case, we maybe say that the requirement was actually maybe defined right. We just chose to test it the wrong way. We misunderstood something along the line, and you can address it as a testing team to say, this is what we're going to do in future to be able to better address these things. Maybe it's training, maybe it's better documentation around it, maybe it's just some guidance in your test cases to be able to then structure a little bit better, and you can maybe then look at how you're writing your test cases to better clear this up. There's a lot of things that we can do, but it's understanding these things better. And again, with everything, trying to ask the questions a little bit more to understand what can we do to prevent the software or prevent the issue from happening, in the first place, and constantly looking at that and constantly going back and capturing this data and then looking back to understand what actually is going on. And over time, you can start getting to things like that pie chart we saw, and you can start to track it. And I think that's an important thing, is you start to measure your change. Are we getting better? So if you're constantly keeping track of your software issues, and I'm a firm believer that you don't need to log every single issue you face within a sprint team, because it does slow you down. Sometimes you just you can be working with your dev, you see something right there, they fix it straight away. You don't have to log everything. I feel like it can be a little bit time consuming, but it's important that we try log as much as what we can, and particularly when we've maybe missed a sprint cycle, or we've maybe the testers found it, but they found an issue with something that, quite honestly, should have been caught in a unit test. Definitely log those type of things, because that's important. And then when you constantly log in everything, you get to a point where you're able to start measuring the change and see, well, we've identified these root causes, we fixed them, but over time, we start having a look at that pie chart again. And well, are our coding issues really going down? And if maybe they're not going down, are they at least going down in those modules that were causing the problem? Are we getting better? Are those modules now becoming a little bit better, and we're happy with the quality that's getting introduced? I think that's an important thing to do. And so I think if once we measure that change and we understand what's going on with our software, I think it can lead us to be able to design in better software. It is a complicated topic. There is a lot to talk about in terms of different types of defects that you can find and the different type of root causes that can be identified to fix them. I didn't want to go into too much detail here, because if you're going to try and label every single type of defect you find, we're going to be here for a long time. What I'm hoping you get from this talk is really some tools or some blueprints to be able to go to your teams and just start asking the right questions. Hopefully to get your team into a better habit of not just closing defects, but stopping to really understand what went wrong in the first place. And then also just to have a look at, how do we classify them? So again, you can't do this with every single defect, but if you can high level say, okay, well, we know this was a requirements issue, we've gone into things, we can start to identify trends and then maybe tackle them at an organizational level, so that you can start to have a better understanding of what's going on. And every single team can start to use your defect tracking tools to be able to say, well, the root cause for this was this, or we believe it was that. And then as an organization, you start to take all this analysis that you're getting, and then you can start to tackle it at a bigger level, because sometimes that's needed. So there's not just teams working in isolation. So it's important that we use the like tools that are there for us, use our defect tracking tools correctly, make sure that we stop to ask the right questions. But I think most importantly, that we take the time to really understand what's going wrong with our software. Thanks so much for this, for listening to this talk. I want to open up the floor to any questions.
Thank you so much, Craig. So we have a question from Derek. Have been confused on the difference between issue and defect?
So the reason why I use the words issue and defect is because an issue is anything that can kind of happen with our software. It doesn't mean that it's a defect. Sometimes we can raise issues and we can analyze it and realize, the code is supposed to work this way. And so, it's not really a software defect. And so that's why I use those terms loosely. Not everything you find is an actual bug or a defect. Sometimes it's just something that happened, and it's not necessarily an issue with the software. Maybe it was designed to work that way. Maybe you guys investigated a little bit further and you realize nothing we can do about it. This is the way that our libraries are going to work with the different sort of things, or this is a constraint of of the system that we have, and we're going to live with it. You can choose to then say that's not really a defect, and that's why I use those terms loosely. A defect is something that you can definitely trace to. This is something that we've done wrong, something that's a definitive problem with our software or our process. It doesn't again have to be your software specifically. It could just be something that's wrong with your process that could be improved. And some of these things that you can do to fix them aren't necessarily just fixing code, but fixing processes, or training people differently. Sometimes if we find actual issues with that, it's definitely a defect, but sometimes we're just raising things and we're not so sure, and they become issues, and then we can delve deeper. So it is a bit of a loose sort of definition between the two, and so I sometimes do use the phrases issues and defects very loosely. Not every issue is a defect, but every defect is a type of issue, if I can put it that way.
Thank you so much. If anyone has more questions, please ask here. Or is it so full enough, so comprehensive enough to remain no questions, I guess. Craig, thank you so much for this valuable presentation. Thank you for being here, contributing and supporting us. It was so nice to meet you and have you here.
No, it was a pleasure. I really enjoyed giving this talk. It's a topic I'm passionate about, and people are welcome to contact me outside of this forum. If you do have any questions, please contact me on LinkedIn or Twitter. I'm definitely happy to discuss about these things further, particularly if maybe you want to find some answers to specific problems that you're facing. I understand in this talk I've gone very high level because there is a lot of different types of root cause and a lot of different types of software issues that we can face. But if you do want to ever delve into something a little bit more specific and you're not so sure how to address it with your team, or how to address an issue like that long term, definitely happy to talk about that further.
Okay, thank you so much.
Okay, thanks so much, guys. Really appreciate it.